want to find tangent equation of normal, all these things we can use derivative. So we'll explain all these things one by one. So to start with, application of derivative is used to determine rate of change of quantities. It is also used to find, as I told, equation of tangent and normal to a curve at a particular point. Please note tangent or normal to a curve at a point, because when I'm talking about tangent or normal, I'm talking about at a point, because at this point this is my tangent. For the same curve at this point, this is my tangent. So the tangent and normal varies from point to point. So this is a must. Also, it is used to find approximate values. We'll discuss more about all these things. It is also used to find the turning point in the graph, and that is used to find local maximum. For example, you have this kind of functions and you want to find what is the maximum value, what is the minimum value. We can use derivative to find such kind of values. We'll also use derivative to find whether the function is increasing or decreasing function. For example, this is my graph and this is my function, right? So if you see this kind of function, this guy is increasing from this interval to this interval, correct? And it is decreasing from here to here. So if I want to find which interval it is increasing, which interval it is decreasing, those kind of things also we can find using derivatives. So these are some of the practical application of derivatives in a real life: the rate of change of quantity, equation of tangent and normal, approximate values, maxima and minima, smallest or largest value, or increasing or decreasing function, correct? Rate of change of quantities. Let's take one example. So if I have my general equation, y is equal to fx be a general equation I have, and now in this case it says y varies with x. So both are dependent actually. It is not that both are independent. This is a function where y varies with x. Both are dependent. For example, let's suppose y is equal to 3x square plus 2x plus 1. This is one example where y is dependent on x. So one equation of y is equal to fx form where y is dependent on x. Then my dy by dx we have studied is nothing but f dash x. Now dy by dx at some point x is equal to x naught is nothing but f dash x naught. This is also we have learned. Also, if you have two variables and where x and y vary with respect to t, x and y are not directly linked, but they are indirectly linked with respect to t, where I say f is equal to x is equal to ft and y is equal to gt.